So today we look at we are starting with special angles. Special angles. How do we obtain them? Two ways. The first one, I'm looking for the angles 0, 30, 45, 60, and 90. I want to find for sine. I want to find for cosine. I want to find for tan. I want to find for sec. I want to find for cosec. I want to find for cot. So what do I do? Say, okay, this can be a table. Some people like it as a circle. So I'll start as a table. This line is bent here. So don't worry, I'm not doing much. I'm just going to do for 2. The other parts are for you. Sine 0. To have an easier way, you say, okay, why can't I just count from 0, 1, 2, 3, 4. And for cos, I'll count in reverse. 3, 2, 1, 0. And divide everything by the 4. Everything by 4. Everything by 4. Then get the square roots. Get the square roots. So when they ask me to find, what sine 0 is, it is just 0. Sine 30, 1 over 2. Sine 45, root 2 over 2. Sine 60, root 3 over 2. Sine 90, 1. Here, 0, half, root 2 over 2. Root 3 over 2, 1. Then, you saw yesterday we said that if you know sine, if you understand sine and cosine, then you have an easy way of understanding the whole trigonometry, because tan is just sine over cosine. Sec is just 1 over cosine. Cosec is just 1 over sine. And cot is just cos over sine. Or is just 1 over tan. So the idea is, since you have for sine 0, automatically you have for tan 0. Because you do the sine 0 over cos 0 that you have. You do the same for sec, the same for cosec, the same for cot. So at your own time, when you're waiting for a meal, when you go for dinner, you are doing this as you are being saved. You can complete this table. Do we have questions here? I want to give an alternative.
Yes, sir.
Please ask.
On sign 45, you've written the square root of 2 over 2. Now, when I do that on my calculator, it's giving me 0.7. So am I supposed to round it off and write 1? Or I just leave it as 0.7?
You just leave it as root 2 over 2.
Okay.
Don't convert it to decimals. We like it this same one.
All right.
Then we can also use so the idea here is you want to find an easier way of remembering this thing. So you can use the counting method from 0 to 4 and then divide by 4 for sine. And for cos, you start from 4 to 0, then divide by 4 and get the square roots. That's all. Let me give you an alternative. An alternative is using the special angles. I mean the special triangles.
Sir, the previous board.
Why are we using the square roots? It's a long story.
Thank you, sir.
Sir,
Hello.
can you please show us for 10, then we do the rest by ourselves? But sir, why not?
That is just sine over cos. What is 0 over 1?
It's undefined, sir.
0 over 1.
Yes, sir, it's undefined. Oh, no, it's 0. It's 0.
Thank you. So tan 0 is going to be 0. Is it? What will be tan 30? It will be sine 30 over cos 30. Sine 30 is half. Cos 30 is root 3 over 2. This can be written as half multiplied by 2 over root 3. So you get 1 over root 3. Where you find 1 over 0? Tan 90. Tan 90 is sine 90 over cos 90. So we get 1 over 0, undefined. You write undefined. And you see this when you do the graphs of tan, what the undefined mean. I don't want to make you lazy. I want you to be good people. Special triangles. 1. One is here with this as 45, that as 45. This means that this one is going to be 90. and then 1, 1. So the other one is going to be root 2. SOHCAHTOA gives us sine 45 to be opposite over hypotenuse. If you rationalize this number, it's going to be root 2 over 2. Cos 45 adjacent over hypotenuse. If you rationalize this number, it's going to be root 2 over 2. Tan 45 opposite over adjacent, which is 1. So still in the same way, you get sec 45 to be 1 over cos 45, which is just 2 over root 2. You get cosec 45 to be 1 over sine 45. This is just 2 over root 2. You get cot 45 to be 1 over tan 45, which is just 1. Why are we rationalizing these numbers? We just wanted them to look like these ones we have found here. Though in mathematics, the reason why you learned how to rationalize is so that you should be rationalizing when you find such numbers.
Sir,
Hello.
can you just please go back to the previous board? I just want to take a screenshot. Thank you.
Question 2. Triangle 2.
So wait. So meaning this special triangle, it's only for 45 and 90, or only 45?
What is the adjacent of 90?
One, sir. It's one.
That's a lie.
Sir,
So, so we use it for 45.
only for 45.
Uh,
All right.
Another one.
So would you kindly repeat your explanation on this angle for this 45-degree angle?
Okay. The triangle itself composes of equal angles inside, so the sides must be equal. So from a long story, we pick that the sides of the base of the opposite and adjacent are 1 and 1. And so we know using Pythagoras theorem how to get the hypotenuse. So we add the squares of 1s. So we'll have a 2, then you get the square root. So that we have this root 2 here. But once I have this combination here, then I go to SOHCAHTOA. Another long story. Sine is opposite over hypotenuse, so we get opposite over hypotenuse. Cosine is adjacent of hypotenuse, so we do the same. Tan is opposite of adjacent, so we get the opposite adjacent. Sec, what do I mean by sec? We just said that sec is 1 over cosine. Cosec is 1 over sine. Cot is 1 over tan. So when you're looking for sec, you use 1 over cos. When you're looking for cosec, you use 1 over sine. When you're looking for cot, use 1 over tan. That's how you find the triangles. That's how you find the angles using that triangle there.
All right, sir. Thank you.
Okay. Now we are forming another triangle. So we are saying another triangle is going to be of this nature.
So I have a question. How come 1 over square root of 2 is becoming square root of 2 over 2? How's that happening?
1 over square root of 2. Rationalize. How do you rationalize the root 2 in the denominator?
So I remember to multiply it times root 2 times root 2.
Thank you. So we pick an isosceles triangle, isosceles equal angles, equal sides, if we cut this into 2 equal halves, automatically this guy here will form a 90 either side. And this one here will remain as 30. This one will remain as 30 because they're cutting 60 in between. And what was 2, this side will be 1, the other side will be 1. So you can extract a special triangle here of this nature. Sixty here. Sixty here. 30 there. 90 here. 2 there. 1 here. Pythagoras theorem, what to the other side? It will be 2 squared minus 1 squared, which is 4 minus 1, which is 3, and then get the square root. So we have 2 sets now. We can get sine 30. Sine 30 is going to be, sine is opposite of hypotenuse, so opposite is 1, hypotenuse is 2. Cos 30, adjacent of hypotenuse, adjacent is adjacent is root 3 of hypotenuse 2. Tan 30 opposite over adjacent, so 1 over root 3. Sec 30 sec 30 is 1 over cosine, so it is 2 over root 3. And cosec 30, 1 over sine, so it is 2. Cot 30 is 1 over tan, so it is root 3. Sine 60, opposite, root 3 over hypotenuse 2. Cos 60, opposite, now is adjacent. Adjacent 1 over hypotenuse 2. Tan 60, opposite, root 3 over 1. Sec 60, 1 over cosine, so it will be 2. Cosec 60, it will be 2 over root 3, 1 over sine. And cot 60, it will be 1 over root 3. If we go back to, in any of these, sine 90, sine is opposite over hypotenuse. So 2 is the opposite of 90, with the same being the hypotenuse, so we get 1. Cos 90 is adjacent over hypotenuse. The adjacent is 0. The hypotenuse is 2. So we get 0. So we have sine 91, cos 90, 0. Questions?
So wait, just stay
Would
on
you
the
kindly read
90.
sign in? Yeah, on the 90 there.
So Katoa says opposite of a hypotenuse. What is the opposite of that 90 there?
It's 2.
What is the
2.
hypotenuse of the triangle?
It's also 2.
So 2 over 2 is 1. Or you go to the first one, it will be root 2 over root 2 is 1. For cos 90,
Then
what is the adjacent of 90? What's the length of the adjacent of 90? It's 0 because
It's
we
1.
can't see it. Eh? What is the adjacent?
0.
It's a distance between the angle you're talking about to 90. So the distance between 90 and 90 is 0. So you have 0 over hypotenuse. So you get 0 over 2 or 0 over root 2. So that you get 0.
And what is tan? What is tan 90? It's undefined, right?
Tan 90 undefined.
Okay.
What about sec 90? So all those will come as a result of your divisions.
So sec 90 is undefined.
Yeah, very undefined.
Why is it undefined tan 90? How?
Tan 90.
Yes.
What is tan?
Tan is opposite over adjacent.
What is tan in terms of sine and cosine?
Cos
sine
over
sine over cosine.
Sine over cosine. So tan 90 is sine 90 over cos 90. Sine 90 is 1. Cos 90 is 0. 1 over 0 is undefined. You know how we should be reasoning in mathematics? You reason by writing.
No?
So when you start asking yourself question, how? Write it. So how 90? So you write tan 90. How is it undefined? Oh, what is tan? Tan is sine over what? Over cos. Oh, what is sine 90? What is cos 90? Ah, undefined. Have you seen that?
Yes, sir.
Even in the exam, that's what you do. You don't just say, these numbers are too big. You write. They will become small. So quickly, we look at the compound identities. There are what we call master identities in this life, and also those that helps to prove, and also those that are proved using those that we call master identities. One. Now this one is above compound. So this one, there's what we call the most important identity. The most important identity. It is sine squared x plus cos squared x is equal to what? If you this any other, this one. What are identities? Identities are known facts in mathematics, like this one. They even have no definition. They're just facts. Then now we can talk about compound ones. Someone wanted to ask a question. They have stopped. Okay. One.
Sir,
No?
is it the same when you write sine x squared and sine squared x?
What you are saying in the end of brackets? You mean this?
Yes.
It's not the same. What is the same with this? So where the x just is squared is not the same as sine squared x. So we start sine A plus B is equal to sine A cos B plus cos A sine B. If I put minus, I'll have minus there. 2 cos A plus B is equal to cos A cos B minus sine A sine B. If I put minus, I'll have plus there. Don't confuse them. You can see how I'm putting them. Okay, let me change the colors. Oh, this one also. Plus, plus. The other one, if there is minus, there will be minus there. This is B. So the other one, if there is minus, there will be plus here. 3 sec A plus B is equal to 1 of cos A plus B. The good part is that you know what cos A plus B is, so that if there is minus, you also use minus. Cosec A plus B is equal to 1 of sine A plus B. So that if there is minus, there's minus. If I'm dealing with tan A plus B, this guy is equal to 1 is equal to tan A plus tan B over 1 minus tan A tan B. So that if there is minus, here too there will be minus and here there will be plus. There's a difference in the signs. So that cot A plus B will become 1 over tan A plus B. So that if there was minus, you also use minus. 6 compound by 2, 12 compound identities. So we can see just from here that we can produce another identity. If we had sine A plus A, it would have been sine 2A. So instead of having sine A cos B, cos A sine B, it would have been AA. So we're just going to have 2 sine A cos A. So you could see also that if it was minus, you get 0. So there's nothing. So cos A plus A, we could get cos 2A. But on the right hand side, it would have been cos squared A minus sine squared A. So as you go down, things would happen like that. So you talk of sec 2A would have been 1 over cos 2A. You talk of cosec 2A would have been 1 over sine 2A. You talk of tan 2A, it would be 2 tan A over 1 minus tan squared A. So that if it is cot 2A, then you just get 1 over tan 2A. If we went back to the most important one, we could see that sine squared A is just 1 minus cos squared A. And cos squared A is just 1 minus sine squared A.
Sir,
Hello?
the 12th, is it 1 over tan 2A or tan squared A?
Tan 2A.
Thank you.
So when it cuts, we join quickly.
Save the board.
Shishita. Shishita. Ih, Lekafeshi. Lekandere.